Boom! Yes, folks, you may again, how are you going? So, in this video, we're continuing with our series of videos where we're discussing the general properties of a circle, right? So, in the first video, we spoke about certain general properties of a circle. This video here, we will talk specifically about the angle. What is the angle? What we mean when we say that an angle is subtended by a chord, subtended by an arc, all right? And then we'll use that as a launching pad to push out into some of the other stuff where circles are concerned. So what is an angle? Now, like so many things in maths, we know instinctively what an angle is. We may not be able to give a concrete word for word paragraphical definition if I could compose a word on the fly, extemporaneously, so to speak. Now, don't use the word paragraphical in your English essay, all right? For the Form 5s and for those of you who do in English as well. Maybe it is a word, who knows? Hold on. Let me see if paragraphic is a word. Hold on, give me 2 minutes here. Let me check my phone. Paragraphical. Paragraphic. Yeah. Paragraphic. No, I ain't seeing that as a word. Paragraphical, okay. Paragraphical format, Papa, you look trouble. Paragraphical, okay. It seems to be a word, alright? Paragraphical, it sounds wordish, it sounds word-esque, it sounds wordy. But for those of you who are tempted, double check that word before you use it in a more formal setting, alright? I have a certain amount of poetic license here. That is not something that you will enjoy in an English exam. But we proceed. So let us define what is an angle using words and letters, right? And I would have been able to source a particular definition online, which I think is good. And of course, I would have made my particular tweaks to it. And the definition is as follows. An angle is the space formed between two intersecting lines. I think we could all understand that, all right? Two intersecting straight lines. Very important. The lines have to be straight. If the lines are not straight, then we cannot consider them as angles, all right? At least where we're talking about the geometry of plane surfaces. What is a plane surface? A plane surface is simply a flat surface. Whether you're talking about a page on a table or a whiteboard on a wall. All right, that is as simple as we want to get it. Of course, we could get more complex than that if we want to, but we really don't want to right now. Good. So, an angle is a space formed between two intersecting lines. Yeah, there's the angle right there. Come, we have to make the line a little straighter than that, man. Come on, man. We now talk about the line needing to be straight. All right. So this is an angle here, and this is an angle here. So in other words, where the two lines intersect, you actually have two possibilities. However, we define the point where the angles meet as the vertex. So in other words, the point where the lines actually meet to cross is the vertex. And based on whatever we want to do, we define the angle that we're talking about. So based on the intersection of these two lines, we could define an angle like that, or if we have the same two lines intersecting like this, we could speak about this angle here. All right? And we could eliminate these two from consideration. So when we have two lines intersecting or two lines meeting at a particular point, the space between the two lines is referred to as an angle, and the point where the two lines meet is called the vertex. So this is angle and this is vertex, right? Right, and that's the angle. So we have an instinctive understanding of what that is, but we could go further. The two lines that meet to form this angle are what we refer to as the rays of the angle, or the sides of the angle. All right, sides might be a little more understandable to a broader mass of people. We could talk about the sides of an angle. All right, from the time we talk about the rays of an angle, which is a little more technical jargon, we immediately step into physics territory now. Where we're talking about a ray of light, and we know that light travels in a straight line, etc., etc., etc. But we will leave that alone for now. So let us stick with the sides of the angle. All right. So the two lines are defined as the sides of the angle. Just keep the word ray in mind. You could chuck it in the back somewhere. All right. The rays of the angle or the sides of the angle. So if you want to use fancy vocabulary, you could describe this line as the ray of that angle. This line is the ray of that angle. By the same token, this line is the ray of that angle, and this line is the ray of that angle. The ray, more commonly known as the side of the angle. Pretty straightforward. Now, what do we mean when we say that a particular angle is subtended by something else? Anything could subtend an angle, right? And in a general sense, whatever the thing is that subtends the angle would usually have the sides emanating from the extremities of the thing, whatever it is. So, look at the diagram in red. If this here is, let me say, that is the Hyatt on the waterfront, right, in Port of Spain. All right, that's the Hyatt on the waterfront in Port of Spain, and we can say for the sake of argument that the angle subtended by the Hyatt at a point 50 meters from the base is, let me say, what are looking like? That looking like a 45 degrees. Let me say 45 degrees. All right. We're not going to try to define what a degree is in this video. We'll do that in our next video. All right. We could also say that the angle subtended by the same Hyatt at a point 100 meters from the base is, let me say, 30 degrees. And we could say that the angle subtended by the same Hyatt, yeah, at a point 150 meters from the base is, let me say, 15 degrees. So in other words, even if the thing that is subtending the angles remains constant, if you change the point at which the angle is subtended, then the angle naturally would change. All right? So when we talk about something subtending an angle, it simply means that the sides of the angle would extend to each extremity of the thing that is subtending the angle. All right? I tried to talk this one out. I didn't really quote. In fact, I have a definition here that I could quote. No, forget that. I'll deal with that when we get to the circle. All right? So this is just to demonstrate the basic point. Anything could subtend an angle. It all depends on where the angle is. So for example, the same Hyatt could subtend an angle of, let me say what? It could subtend an angle of, what are looking like? Are looking like a, let me say at 30 degrees now. It could subtend an angle of 30 degrees at the top of a ship that's passing by, right? The mast of a ship or something. So it doesn't, in other words, the point where the angle is subtended, being subtended, could change. The thing that is subtending the angle remains constant generally, but the point at which the angle is subtended is important. So you have the thing that is subtending the angle. You have the point at which the angle is subtended. In other words, that point is where your vertex will be. So in this case here, where we're subtending at a distance of 50 meters, the vertex is here. And that will give you an angle of 45 degrees. In this case, where you're subtending at a distance of 100 meters, the vertex is here. And that will give you 30 degrees. And then in this case, where you're subtending at a distance of 150 meters, the vertex is here, and the angle is 15 degrees. All right? In this case, you're subtending at the top of the mast or the ship, whatever it is, right? I'm not too familiar with the ship vocabulary. Ship vocabulary, right? If you're subtending at the top here, then this here will be a vertex. And that is what will give you an angle of, well, in this case, the angle is 30 degrees. All right? So, anytime we talk about subtending, we must refer to what we must ask ourselves the question, what is subtending this angle? Then we have to ask ourselves, where is the angle being subtended? And once we answer those two questions, everything else would follow as a matter of course. So now, what I will do now is to take these same concepts and transplant it into the realm of the circle for further explanation. All right. Whew, pressure, boy. What do you think, boy? Hey, what? We could just use the sandman. You're doing quite a good job, actually. Ahí va. Atoina susua 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 susua. All right. All right. So 5, 4, 3, 2, 1, 0 and 5 4 right, 5 4 3 2 1 0 and boom. All right, so we continue with our discussion. Now where a circle is concerned, all right, the two entities which we would have described among other things in the first video in this series, the two entities that are usually presented as subtending a particular angle would be a chord and an arc. Right now, of course, remember once you have a chord entering the picture, you'll automatically have a major arc and a minor arc. So the chord could subtend an angle, and where are the angles in a circle usually subtended? The angles are subtended either at the center of the circle or at the circumference of a circle. Now, a chord could subtend an angle somewhere else in a circle too, and you will find that coming into play in some of the questions where you have a whole set of lines and figures and quadrilaterals and triangles and stuff within a circle, and you have to deal with chords or arcs subtending different angles in different places. But generally speaking, the chord or the arc would subtend an angle either at the circumference or the center. That is your foundation. Everything else would spring from that. Yeah? So let us start with the chord. We're going to name this chord AB. That's the chord A, B, A, B. Alright? So we could say, remember of course, that we have a minor segment and a major segment. Well, sorry, a minor segment and a major segment. You have a minor arc and a major arc. Same thing would hold for this particular circle. So we could say that this chord AB subtends this angle in the major segment. Alright? We could also say, however, that this arc AB subtends the same angle. Alright? Remember the example we did in the previous video, well, not in the previous video, earlier in this same video, where we spoke about the Hyatt subtending different angles at different places. Right? Now, the two endpoints are identical. So whether we refer to a chord subtending the angle, or we refer to an arc, in this case the minor arc, subtending the angle is well, truly, and properly subtended. Alright? Same story over here. If we have this arc, in this case, it will be the major arc. Alright? Ooh, yeah boy. All about man, you know how it is when you're doing things in real time. The whole thing does get slowed down a little bit, but we had to do what we had to do, right? We don't always have the luxury of preparing a nice pretty diagram 100% before we start to talk. Sometimes you have to do what you have to do extemporaneously. You have to stop while you're talking and draw a diagram or explain something that is in nature of this thing that we're doing here. Alright, so let us say, for the sake of argument, that this same chord AB, right, same endpoints. Remember, the endpoints are important. The endpoints are what lets you know what is doing the subtending. So when we saw the Hyatt, we had the top of the Hyatt and the bottom of the Hyatt at the base, subtending different angles at different locations. In the same way, this chord could subtend an angle in the minor segment. Alright? Now, whether we describe the angle as being subtended by the chord AB or being subtended by the arc AB, right? In this case, the arc is the major arc. So you have the arc AB versus the chord AB over here. in this case, you have the same arc AB and the same chord AB. Alright? In both cases, the chord is the same. The chord is the same between the two circles. Alright? And we have the same chord subtending angles in different segments. So this chord AB could subtend an angle in the major segment, and this same chord AB could also subtend an angle in the minor segments. And you'll see that taking place as we go on later into the theorems. By the same token, we could consider, because the endpoints are identical, we could consider this angle as having been subtended by the arc AB, which in this case is the minor arc. The minor arc subtending an angle in the major segment. And by the same token, we have this angle here, which we can consider as having been subtended by the arc AB. In this case, the arc is the major arc subtending an angle in the minor segment, right? So in this case, we have the arc AB is the minor arc, right? And in this case, the arc AB is the major arc. Alright? Now, the same chord. Remember, the chord is the same. Chord AB is equal to chord AB. Alright? So in other words, every chord, as we explained in the previous video, remember we discussed this, but as always, we repeat. One chord, the same chord AB will generate two arcs. The same chord AB will generate a minor arc and a major arc in the circle. Chord AB, minor arc, major arc. Chord AB, minor arc, major arc. Alright? Which means that the extreme points, the extremities, so to speak, or the extremities, if you want the song more, you know now, pronounce this thing with a little more. Right? The extremities of the chord AB would be the same as the extremities of the minor arc AB. Likewise, the extremities of the chord AB over here will be the same as the major arc AB. So when we say that this chord subtends an angle in the major segment, and the same chord subtends an angle in the minor segment, we could also describe it as this minor arc AB subtending this angle, and we could describe it as this major arc AB subtending this angle. Now, we could also have the subtending taking place at the center of the circle. So this major arc, let me see. This chord could subtend an angle at the center of the circle. This chord AB could subtend an angle at the center of the circle, which would be here. So in other words, this chord AB, which I will blacken here now, subtends an angle at the center, and we could also describe that angle as having been subtended by the minor arc AB. Alright? By the same token, this chord could subtend an angle here. Alright? Because the points, the extreme points are the same. And just as over here, you have two radii. Of course, this angle is now an obtuse angle, which means that is obtuse? No, reflex. Obtuse is between 90 and 180. Reflex is greater than 180. Alright? So this is now a reflex angle. So while in theory, it is the exact same thing as this, from a visual standpoint, from a conceptual standpoint, the subtending is easy to pick up if the angle is less than 180. So you could pick it up here, you could pick it up here, you could pick it up here. You wouldn't naturally see this chord as subtending this angle here. However, if you describe it as the arc subtending the angle, then yes, you could pick it up faster. Because at that point now, you have the arc here, the major arc subtending this angle here at the center of the circle. Alright? So the description of the arc subtending at the center of the circle is useful once the angle is reflex. Once the angle is greater than 180, yes, it is easier to visualize the arc as the thing that subtends the angle versus the chord. I just wanted to remember, however, that it is the same thing, two sides of the same coin. Alright? I guess you have the freedom to choose which one you want to refer to. I am sure there are people who would understand the arc better. I have a personal preference for the chord. And the reason why is simply one, that is how I learned it when I was back in school, in whenever. But even more importantly, the fact of the matter is that in circle theorem questions, you usually have a cacophony of lines to deal with. A preponderance of lines, straight lines. You have a whole set of lines. You have chords, you have tangents, you have the sides of cyclic quadrilaterals, you have the sides of triangles. Alright? Sometimes you have more than one tangent, etc., etc. So you have radii, you have diameters. So most of the discussion around problems and questions where circles and circle theorem are concerned would inevitably revolve around a series of straight lines. And it is for that reason, and that reason more than anything else, that I prefer to consider the chord as the thing that does the subtending as opposed to the arc. The only tricky part in that would be this scenario here, where the chord subtends an angle, right? In the, let us see. The chord subtends an angle, how to describe that, boy? Let us see. The chord, in this case, the chord subtends an angle, forget that. Let me just look at what we have here, right? So even if the words not really coming, you see what I'm saying, and you get what I'm saying, right? And you understand it. So we have to be like a baby here now. You see the thing, you hear what I'm saying, you understand what I'm saying, even if you don't have the words to describe it. All right? This case here is the trickiest case where the subtending by a chord will happen. We will discuss this case in a little more detail, a little more when we talk about some other theorems coming up. But I just want to note, and I want to place it on the record, that this angle here, just as all the other angles we described, where we could have seen them as being subtended by a chord, and the same angle being subtended by an arc. Excuse. This angle too, while we can see easily the fact that the arc subtends the angle at the center, be under no illusion that the same chord also subtends the arc at the center. Alright? The only difference is that the angle is now, you get to 180 and then you move past 180. Right? You become a reflex angle. So once you have that okay in your mind, then yes, we could just go with the chord. Once you go with the chord, you will understand that when you're doing our questions, is chords you're dealing with. And all of the theorems that we could enunciate from this point onward will almost invariably be enunciated in terms of the chord. The chord, the angle subtended by a chord. The angle between a chord and the tangent. The angle subtended by a chord at the circumference, angle subtended by a chord at the center. The angle subtended by a chord in the alternate segment. Alright? But Don't worry about all them things. We will get to those things eventually. And as we go through each theorem, one at a time, one step at a time, we will just get accustomed and comfortable with the chord. Now, if for some reason you prefer to use the arc, then no problem. Right? I am not one of those guys that will try to force my way on a student. I will teach it how I believe I could best explain it and break it down and make it comprehensible to the student. But sometimes, even with your best intentions and with the greatest of skill, a student might still see it a different way, and a student might still be more comfortable seeing it a little different to how you're teaching it. That is fine. If you're working with me, that will not ever be a problem. Alright? I am sufficiently familiar with the stuff that I could adapt. So if I'm in a class and I teach in the chord, and a student somewhere in the corner seeing it as the arc, no problem. It's the same angle. You just have to be very clear on which arc is doing the subtending. That's the only difference. Because a chord is one chord. Alright? So one chord subtending at the center, it's subtending at the circumference. Same chord subtending at a different point on the circumference. Same chord subtending at different angle at the same center. In the same way, you could look at the arc. Right? The same arc subtending at the circumference is subtending at the center. Minor arc subtending at the center, subtending at the circumference. Alright? So once you figure out which arc is doing the subtending, there is only one angle that arc will subtend at the center, and there's only, well, yes, one angle that it would subtend at the center, and that will have a whole set of angles that it will subtend in the alternate segments, which we'll come to not too long from now. And by the same token, you realize you choose this arc, it will subtend one angle alone at the center, and then you have a plethora of angles that the same arc would subtend in this alternate segment. Once you're dealing with the chord, all you have to figure out is which segment we're talking about. So if the chord subtending an angle at the center in the minor segment, then this is the angle we're talking about. If the chord subtending an angle in the major segment, then this is the angle we're talking about. So the same chord could subtend any one of two angles at the center. Alright? One chord could subtend two possible angles at the center. It could subtend an angle in the minor segment. The same chord will subtend an angle here in the major segment. Alright? And yeah. And then of course, once that happens, you find that in this case, having subtended an angle at the center, you have a whole, having subtended an angle at the center in the minor segment, you now have a whole set of possible angles that the same chord could subtend in the major segment. And by the same token, having subtended the one angle at the center, you now have a whole set of angles that the same chord could subtend in the minor segment. So you subtend the angle in the major segment, and then you have a whole lot of angles here that the same chord could subtend in the minor segment. Alright? So that is it in terms of just discussing the whole concept of what is an angle, what we mean when we talk about an angle being subtended, and then we transplant that concept into the circle, and then we make a strategic decision for teaching purposes. Right? We're sticking with the chord. So in other words, we don't want to be flip-flopping between the chord and the arc. That is a recipe for confusion, especially when you start to see all them lines and things. We don't want to do that. You choose one or the other. My choice is the chord. That is what I will teach as a student. If you see it in terms of the arc, no problem. We're not going to argue about them things. Alright? So, that is it for now. The next step now will be to go headlong into the actual theorems themselves, which we will commence in the next video. So as always, stay tuned, stay in the game, go and tell somebody, you come back and bring them back, because you have plenty more coming your way. Boom!